Hi, welcome everybody to the November meetup for Cincinnati Ruby Brigade. We have with us Ryan Carroll, who's going to present on bringing ideas to life with IoT. Visualizing noise pollution sounds really exciting. Ryan, I'm sad I missed the Columbus Ruby Brigade. I was hoping to kind of make it up there and just catch that one in person. So I'm really excited that you are willing to help us out with the Cincinnati Ruby Brigade this month. This will be our last meetup for the year. When we kick back off in January, we might actually start with an in-person format. So we're kind of working through some ideas around that, but stay in touch for that. Um, anyway, Ryan, take it away.
Forgot that I muted myself there. All right. So it is wonderful to meet all of you. So, like Tim said, I gave this presentation a few weeks ago here in Columbus, where I live at the Columbus Ruby Brigade. And I need to get my screen share going because I haven't done that yet. I've been trying to do like presenter, but it takes over all of my screens when I do that, and then I can't see anything. So I might not be able to see you guys, but we will do our best here. So I'm going to share this one. All right, perfect. We are ready to roll. And now I can see everybody too. All right, yeah. So this whole presentation is about bringing your ideas to life that you have with IoT. So we've already been talking a bit about Raspberry Pis and some of the neat things that we can do with them. And they are really great devices. So one of my goals with this is if you have a Raspberry Pi, which most of us have one or 10 sitting around, to actually pick those pies up and do something really fun and cool with them. And it sounds like a lot of you are already doing that, which is awesome and glad to hear. And maybe this will inspire some new ideas aside from the other cool things that you've already been doing with them. So again, my name is Ryan Carroll. I live in Columbus and I'm a senior software engineer over at CoverMyMeds. I work mostly in Ruby and React. And a couple just fun facts about me. I've been a full stack developer for about 8 years now. I love to do things outside, hiking, camping, backpacking, all that kind of stuff. So I love the outdoors and environments. And we're going to be talking a lot about sound and noise today, and I care very much about sound, as you'll see throughout this presentation. And one thing that I do on the weekends is I'm a sound engineer. So I do live mixing for the church that I go to and get to participate in that. So sound is very important to me. And then I've got a QR code here on the screen. So all of the slides here, and then I've got a GitHub repository out there. That QR code should link you to all those resources if you want to have access to them later. That way you don't have to hurry up and screenshot things or write notes down or whatever. You can just get the full deck if you want it. So I'll leave that there for just a second longer in case anybody needs it still, and we will move on. So, what are we going to talk about today? We're going to hit a few topics. We're going to do a brief recap of what IoT is and just define it real quick in case there's anybody that's not quite sure and just bring everybody up to the same page. And then I'm going to do a little bit of a dive into noise and noise pollution and why it is a topic that I chose to look at and why I think it's important and how it might impact you. So we'll take a little bit of a detour there. And then after our detour into the noise, we're going to come back to the technology and we're going to look at a walkthrough of this project itself, go through all of the parts. We'll do a little bit of a deep dive into each of the parts, and then we'll circle back at the end to talk about the results. I'll do a little demo of the dashboard, and we'll talk about what it means for you, some ideas that might inspire you in your own projects. And if anybody has any questions, at any point, just feel free to speak up or raise your hand or whatever. I'm not too accustomed to doing virtual presentations like this, but I will do my best. So, first on the list is what is IoT? So, I've got three pictures here on this slide showing three different things. And who wants to take a stab at what these three things have in common? There's a few different things. There's a couple items in particular that I'm looking for, but really anything goes. So, what is something that these three have in common?
They're outside.
They are all three outside. Yes, that is true. What else?
They all seem to be picking up some kind of sensor information, whether it be optical or otherwise.
Yeah, exactly. That's one of the things I was looking for. So all three of them are sensors, which means they're all three taking readings about the environment that they're in and saving those readings somewhere. And then the other thing would be they all have a network connection at in some capacity. So they've got the sensors on them, they're taking these readings, and then they are sending those readings somewhere for some purpose. And that is really what IoT is all about. You have all of these different devices scattered all over the place that take readings of all sorts of information and they have a network connection. So it's a thing with internet. Um, and they're really all over once you start to think about it. We have smart thermostats, we have Fitbits and Apple Watches, we have phones that have all kinds of data that they record as far as like altitude and how much we walk and accelerometers and all of these different things. They're really everywhere and they do neat and interesting things, and you can put them to use for all kinds of fun projects. So next, we're gonna detour over into noise pollution for a few minutes here. So I'm gonna first start out by defining what is noise pollution. And I like this quote that I pulled from National Geographic. It is any unwanted or disturbing sound that affects the health and well-being of humans and other organisms. And I really want to, I bolded it here. I want to key in on the section there in the middle where it says affects the health and well-being of humans, because the health aspect is what I want to key in on. It's not just noise or it's not just an annoyance. It's something that really affects health and well-being in the end. And I have a definition that goes a little bit deeper here from another source. And it says, to be precise, noise becomes harmful when it exceeds 75 decibels. So decibels is how we measure how loud something is, how loud a particular noise is. And we'll get to more on the decibel scale in a second. But 75 is really when it starts to become harmful. And I'll skip down a little bit. Sleep is impossible when it's in excess of 30 decibels. So when we're talking about noise pollution, we're looking at these different values and how it affects you and what you're trying to do. So if you're in a environment at night where you're trying to sleep, your body needs it to be a quiet environment. We all are familiar with when you go to sleep, you want it to be a quiet room. You don't want music blasting or whatever. There's a baseline need of it to be less than 30 there. And then during the day, as you're going about your day or trying to have conversations or whatnot, 75, we're looking for it to be below that level. So noise pollution can come from a lot of different sources. What are some things that you think noise pollution may come from? And there's no wrong answer, no wrong answer, no right
Cars.
answer. Yes, we will talk about cars quite a bit here in a few minutes, but that is my pet peeve. definitely.
Leaf blowers.
Yep, leaf blowers, loud, landscaping equipment in general, mowers, leaf blowers, that those kind of things. Yeah, those can definitely be disruptive. Any other pet peeves out there?
They pressure wash outside the office about once a week, I think, for some reason.
Yeah.
That's super loud. There's like a generator motor and then the spray, the noise of the water.
And so I'll follow on to that. You guys have mentioned some good things here. How do those noises affect you when you're trying to get work done and there's pressure washing just blasting right outside your door or window or a leaf blower or whatever it is? How does that affect you?
I've personally had problems with loud noises ever since I was a little kid. I got like a Christmas present I got was this little awesome remote controlled monster truck, and I absolutely loved it. But I was also apparently so terrified of it that they took it back. Um,
Yeah.
and there's like I don't know, like it's inside your head and um, kind of bounces around in there and makes it feel I don't know, it triggers a part of my brain that's like fight or flight almost sometimes, depending on what noise it is.
Yeah, absolutely. It induces stress. That's one thing that I face a lot is if I hear something loud enough, it makes you anxious and stressed and it triggers like almost this physical response that gets your heart going faster and you're more alert and you're not like maybe not quite panicked, but the fight or flight I think definitely speaks to it. So we'll get to those. We'll come back to those effects here in a second. But some sources that I have here are airports or loud planes, jets, definitely cars, especially when they're revving the engine or squealing the tires or whatnot. Construction, loud equipment of all sorts, and traffic. Back to the traffic again. So it can come from lots of different places. And I do want to make a note here that something doesn't necessarily have to be noise pollution all of the time. So there's a difference between fireworks on the 4th of July at 9:30 and fireworks outside of your apartment complex at 1 a.m. They're both fireworks. They're very different though. One is absolutely noise pollution. One maybe noise pollution a little bit, but we can be more forgiving with that. So you have to keep that in mind when you're thinking about these things too. So we talked about the effects of how does it make you feel? And I went and did some research, and this was on nih.gov. And I really like this graphic because I think it illustrates well those psychological effects that we were talking about of when you hear these loud noises, how does it affect you physically and emotionally in these different ways? And we can see here that it has these different acute effects, things that happen sharply right away, such as increased annoyance and stress, the fight or flight that kicks in. If it's loud enough, it can affect your hearing and damage your hearing. And then it can also affect your sleep quality, how much sleep you are getting, the quantity, and then when you are able to sleep, the quality of sleep that you're able to get. And of course, all of those things over time funnel into these different conditions, such as hypertension, which leads to heart disease and these different things. So it affects us in a very real way. And one thing that I wanted to do when I was researching this is we know what it does, but what are some numbers to back that up? Do we have numbers on these are the effects and here's how they played out in the real world? And when I was doing this research, interestingly, I wasn't really able to find numbers for the United States. So in the US, we know that it's bad. We know it does these different things, but we haven't really funded actual real world studies to see what's the end result of this. And I ended up having to go to Europe. So they've done some studies in Europe to see how this has affected people. So these are numbers from 2017, and these are numbers across the European Union at the time, and what it has actually done with people. So we have these numbers here of road noise, how many people were highly annoyed by it, how many people was their sleep disturbed, how many people did that result in heart disease, and then at the end there, premature mortality. And yes, this was a wide area, but these are not necessarily small numbers. We can see that this is something that does affect a great number of people, and some of them very greatly. The thing that really stands out to me here is that little metric at the end, the DALY number, which stands for disability adjusted life years. And that's how many years overall have been taken away due to the stress and the different factors that noise has caused. So we can see that it really is something that at least I care about. And here's why I think that we should all care about this in general, because of the effect of what it has on people and quality of life. Whenever I'm talking with people about noise, one thing that they'll often tell me is, you're showing me these decibel levels, but I don't know what that means. I don't know what this number corresponds to. So if I see 45 on the meter, that number doesn't mean anything to me. So I hesitate with showing this chart because it's so busy. There's a lot going on it. So I don't want you to try and read through all of it. But we see that that 75 range is where things start to really get loud. And we saw earlier, that's where it becomes harmful. So if I'm trying to have a conversation with you, or I'm giving this presentation like I am now, and it was 75 decibels or above, we wouldn't really be able to have a conversation with each other. It's kind of think when you're standing out somewhere and there's a bunch of loud traffic going by, and you eventually get to the point where it's like, we're trying to talk, but it's just not worth it anymore. We have to go somewhere else. That's kind of where that 75 fits in. Background music you have at 60, average room noise goes from 30 to about 50. So those are some of our baseline numbers to start off with. So why did I choose noise specifically? What got me started on this whole journey that I've been on? Well, here is a very simple diagram of my house where I'm sitting right now. And in front of my house, I'm kind of on the corner here of two roads. And I don't know how to do the laser pointer, but the road on the right side is it's a main road, and it gets a lot of traffic. And then this other road that cuts across fairly close to my house, and it travels along my backyard. So my backyard is behind my house to the left there, and this road just kind of rides right along it. And when I bought this house, I was looking at the maps and doing research, and I thought, that road's not really going to get any traffic. There's nothing at the end of it, really. It'll be fine. And after moving here and being here a little while, it's been a bit more than I anticipated. And something that has happened quite a bit is there's a traffic light at that intersection that you see there at the right. And what will happen is people will be sitting in a red light. And when that light turns green, they, for some reason, feel the need to just floor their car. And it's not a stock quiet muffler that they're using. It's something that's either modified or it's just not there at all. And it's very, very, very loud. And we've seen with the noise pollution how that affects people. And it started to really affect me a lot over time. And when I first moved here, our windows upstairs were single pane. So this is a really old home. And the single pane windows upstairs, I got to the point where I was barely getting any sleep at night. So one of the first things that I did was have the windows replaced with like new double pane windows to try and block out as much noise as possible. And even then it will still wake me up sometimes depending on how loud the person's car is. So after dealing with this for quite some time, that's what drove me to, all right, I'm always telling people my yard is so loud and it's just loud all the time and it drives me crazy and I can't take it anymore and I'm losing sleep and people would seemingly be like, okay, but it's not really that loud. Like you're just over exaggerating. And over time, I'm like, all right, I want to prove to you exactly how loud this is. And when somebody's driving past, I'm thinking, I wonder how loud that was. Like, how loud was it exactly? I want to know. I want that data. So that's why I decided to build a decibel meter and a dashboard for it. So we've talked about noise for a while. You're thinking, when are we going to talk about technology? Well, we're going to talk about technology for a little bit here. So I'm going to start out with the hardware. So I built a decibel meter. I say built, I put a couple parts together and put some software on it. And the hardware components are pretty simple. So I've got a Raspberry Pi that I've had sitting around in my desk for years that I needed a project for. And I've done things with it here and there, but nothing substantial. So I just had that ready to go. And I thought, this is my chance. I'm going to use this Raspberry Pi for something cool. And this is an older model. So I have the Raspberry Pi 3B Plus, which has plenty of horsepower for what I need to do. Most of the time, you don't really need a beefy Raspberry Pi. You just need a Raspberry Pi or something like it, like an Arduino. And then I found this neat environmental sensor that Adafruit sells. It's called the Enviro chip. And it doesn't require any soldering. You just push it on top of the expansion slot on the Pi, all those little pins there, and it's ready to go. And it has some neat sensors in it. It can do temperature, it can do air moisture, it can do obviously noise levels. It's got a little microphone on it. And they also make an upgraded version called the Enviro Plus, which does air quality. So if you want to do a project involving air quality, you can get the Enviro Plus and do those kinds of things with it. And then on the right side, I just have a server. This could be any server, any computer that you're using as a server. Mine happens to be a Synology NAS that I'm running a bunch of Docker images on, but any server will do. So that is the hardware piece. Now onto the software. So the software, I've got a few different things. If you've done anything on a Raspberry Pi, you probably use Python. So I'm using Python as my language of choice for taking in the readings from the sensors. And then I'm using InfluxDB to store all of my readings in, which I'll talk a little bit more about in a second. And then I am visualizing it with Grafana. And all of this, most of it is running in Docker. So I like using Docker containers. If you are a hobbyist and you like to tinker around and do things with Raspberry Pis and you don't know Docker already, which I'm guessing most of you do, but if you don't, I would highly, highly, highly recommend learning Docker. It just makes things so much easier. So from there, bringing it all together, how does this all look at a system level? So it's pretty simple. We've got the road. We've got people being crazy on the road, real loud. And I have the Raspberry Pi sitting in a cabinet with an open face on my back porch that kind of faces the road a little bit. And it is taking in readings of the audio levels, and it sends those inside across the network to my server, which has InfluxDB running on it. And then I've got an instance of Grafana running, which is hooked into Influx, and it's hosting that externally so that anybody with a web browser can go and access and look at the dashboard and see how loud my yard is at any moment. So I will pause there for just a second. Any questions so far? All right, we'll keep rolling. And I'll pause for questions at the end too. So, okay. So the Python script, we're going to walk through the pieces. So we looked at the hardware, we looked at the software, we saw how it all fits together. How do the pieces come together? So this is the Python script, and I've just got a little small snippet of it here. It's part of a much larger script where the Enviro comes with a Python library. So I'm using that Python library to access the microphone. And there's some generous people online, which I've credited in the GitHub. They wrote the code to convert the audio signal to an A-weighted decibel value, which is actually quite a bit more complicated than you would imagine. Anything to do with audio just gets more complicated than you would expect it to. But the code is out there, and this little function here just takes the decibel reading that the code outside of it gets and sends it to InfluxDB. InfluxDB also has a nice Python library that is very easy to use. So it collects a reading, it waits for about a second, and then it collects another reading, and it just continually does this on a loop, sending all of the readings over to Influx. I need to amend this point at the bottom here. It will run in a Docker container eventually. Right now, it's just running under system control as a daemon task. So I forgot that I put that in there. I am Dockerizing it, but it doesn't actually run in Docker at the moment.
You're Dockerizing it on the Pi?
Yeah, just to make it a little bit more stable. I probably don't need to. Docker might be a little bit more heavyweight, but for me, I think it'll make it easier. So next we'll dive into InfluxDB for just a second. The main reason that I chose InfluxDB, so I almost went with Postgres here just because I've used Postgres a ton. I'm familiar with it. It's free, all that good stuff. But as I was doing some research, I learned that there are specific databases that are time series databases, and they are purpose built for series over time data, which is what I'm gathering here. So I'm taking decibel readings over time, and I wanted to learn a new database system, and this was one of the better time series databases out there, so that's what I chose to use. I mentioned a second ago that it has lots of really good client libraries, including the Python client library, so that also made it a good choice, and it has a direct integration with Grafana. It also has really strong community support, which made this easier because I'm Googling all kinds of questions about, all right, if I'm going to run Influx in Docker and I want to use Docker Compose and set up all these environment variables, how do I do that? And there was a lot of good documentation and resources out there for that, which is important. If you're going to tinker around and it's in a space that you're not necessarily well-versed in, you want to pick something that's got a lot of good documentation and good support. So Influx was a good choice here. Here's a little snippet of my Docker Compose file. So I'm running it obviously through Docker Compose, but what you need to do with Influx is get it up and running. Then you create a bucket to store the data in and segment that out. You'll need to generate an API key for your Python script so that you have the permissions needed to write data into it. And then I already talked about the Python library, and then you just start sending readings to that bucket, which we saw a second ago. It uses a querying language that is similar to SQL. It has a little bit of a learning curve because it's a little bit different, but it's not too bad. Grafana, I'm assuming most of you are familiar with Grafana already, but Grafana has an open source dashboardy kind of thing where you can visualize all kinds of data. It's typically used for monitoring systems, so think like CPU levels and memory levels and latency and these different things. And you can absolutely use it for that, but you don't have to use it for that. You can use it for whatever kind of data type application you want. And I thought it was a good fit here because of the direct integrations and client libraries and support and everything that it offered. It has a pretty robust set of data visualizations that you can create with it, which was also nice. And I mentioned it has the open source version. So it was an easy pick for me for Grafana. I've also got that running in Docker via Docker Compose. So I've got a little snippet of the Docker Compose file here. And you configure the connector between it and Influx, which you can all do within the UI if you want to. It's very easy. Then you just start building a dashboard and building fun charts with it. So that is the how on Grafana. All right, are we ready for a demo? That's what we've all been waiting for. All right, I'm gonna try to gracefully exit presentation mode here and pull this window over. So this is the decibel dashboard. So if you want to see how loud my yard is, it's 53 decibels right now, and this updates every few seconds. And I've got a few different metrics on here. So right now we're just looking at the last 6 hours, and you can see a nice graph of the green line is the mean, and then the yellow line is the max. So you can see some spikes. Today hasn't been too bad. They're doing some construction on my road, and part of it is closed off. So that's greatly reduced the amount of traffic that I've been getting for the past few weeks, which is nice. You can see the all-time high reading. So this was actually a lightning strike, the 97 decibels there. So if you hear lightning strike really close by, it's probably in the 90s somewhere, which is really loud. That's really loud. Before this, my max reading was, I believe, 93, about 93 decibels. And that was from a car. That was from somebody that just like punched it. And I don't know if they were just totally missing a muffler or just had a really loud one, but it was a very, very loud vehicle. The last reading that I've had in the last 6 hours was 72.3. You can see my daily averages here kind of hovering in the low 40s for the most part. And then this down here, I've got accounts above 80. So every day, how many times did it go above 80 decibels? And I need to fix this. It says last 7 days, but it's really quite a bit more than that. And these right here, there were times when the meter went down and I just wasn't paying attention to it for several days. So it just wasn't reading anything. That's what most of these gaps are. But you can see like this was midsummer with peak driving and motorcycle season. It was pretty loud. I was getting lots of days where there were 3 or 4 instances where it broke above 80. So if you remember, that 75 is when it's like really loud, and this is even louder than that. And there was one day where it was just crazy and I had 12. So that's the dashboard. If we look at, I think let's go back to July and we'll do this time range. Give it a second to update. There's one particular night that I want to show. Oh, it's not July, it's June. Let me go back. June. A really nice feature of Grafana is you can set date ranges and get really specific with how you drill into your data. Yeah, let's do this. Let's look at this range. It's still loading, so I might. Yeah, there we go. So we've got 22 is what? 10 p.m. 75, 50. Let's see, what is that? 57. So there were a few nights where I'll have to go back and find it and write down the specific date stamps, but there was like one night where it was 1 a.m. and there was a 70 and a 75 of just like all hours of the night, just really, really loud cars going past. So that is the dashboard. All right, I'm going to try to get the presentation back up here. There we go. All right, so what's next? So I've done this project. I've collected a bunch of decibel data. I have a dashboard. How could I expand it? So some ideas that I have for things that I want to do are I want to deploy more Raspberry Pis to additional sites. So I live in a louder area. My parents live in a quieter area out in the countryside a little bit. So I've got another Raspberry Pi here that I'm not using, and another microphone that I just bought from Micro Center. This one's not an Enviro, but it's just a little tiny, I don't think it's going to focus on it, but it's just a little tiny microphone chip. But I could take this and I could put it at my parents' house and start recording data from there and have that feed into my dashboard. And then I could do some charts with 2 lines and see how do these different areas compare to each other. I don't have to necessarily do just 2. I could do like one inside my house, one outside my house. Yeah, Tim.
Do you have to do anything to calibrate the microphone in terms of like make sure that it's picking up the right volume
A little
of?
bit, yeah. So I have a like an actual tool that is specifically for reading decibels that I use, especially like when I'm mixing live music and stuff. So there is a little bit of calibration. I think this was uh, originally about 2 or 3 decibels off. So it wasn't off by very much, but there was still a little bit of calibration to do. Yeah.
Is that something that's built into the library you're using, or do you just factor it in after you?
I would just factor it in after. There's probably a more scientific way to do it, but
Is it a linear thing where it's always like 2 off, or is it you have to fit to some kind of curve or something?
in the ranges that I'm in, it's fairly linear, but decibels in general are not linear. They're logarithmic. Yeah. So that's a great question.
So you haven't measured inside your house?
I have not yet, but I want to. I have a daughter who just turned 1 today, and she's pretty loud, so it would be fun to measure inside the house as well. So yeah, deploy to additional sites, and it would be neat to see the comparison between inside and outside, or my house and some other house, and how all of those relate to each other. You could also use this to build some kind of action plan or proposal to the city. So now that you actually have like data to back up what you're saying, hard factual data that always grants a bit more credence to an argument. Machine learning is all the rage at the moment. It's been the rage for a while, but now it's getting more and more accessible as we have easier access to lots of different models and things. But when it comes to machine learning, what is it that you need a lot of? You need a lot of data to train models. Well, what better thing to train a model on than data that you've collected yourself, your own data? Then you can train your own model to do all kinds of different neat things. So if you want to get into machine learning, then maybe you should consider a side project to collect your own data and use these different IoT sensors to do that. You could try and correlate noise to weather. So maybe when it's nice and sunny and the temperature is warm, more people are out driving and it's louder versus colder weather, or it's rainy and less people are out driving. There could potentially be a correlation there. Same thing with the time. You could also use it to identify the source or the type of noise. So this could be, was this sound a bird, or was it a semi truck or a motorcycle or a passenger car? And then you could maybe graph out, of all the things that passed my house, this many were cars and this many were that. And you could create even more visualizations that way. But it doesn't have to just be about noise. So one thing that I want to stress with this project is you could use this type of setup or architecture for all kinds of different things. You have a sensor that collects data of some sort, and you feed that to a database, and you feed that to a visualization system. And it doesn't have to be sound necessarily. It's a really easy pattern that lends itself to all kinds of different fun projects. So what are some things that you can do? And this is really where I put the question on you guys of, I'm passionate about noise, but what are you passionate about? Is it weather? Is it air quality? Is it soil quality? You know, there's all kinds of different applications that you could apply this stuff to. So maybe you want to measure air quality and UV exposure somehow and maybe correlate those to each other. Or you want to track wildlife. Maybe you live in the countryside and you have cameras and you want to see like movement of wildlife in your yard and see what's visiting your yard or the frequency or whatnot. Or you want to measure like the pH balances in your water and see how that fluctuates over time. You could track garden soil, moisture. You could set up a camera to correlate that to plant growth over time. There's all kinds of different things. So I'll turn the question to you guys. What are some ideas that you guys have that this has sparked, or what is it that you care about that you would like to potentially do a project on?
Two of the interesting things that I've either been involved in or seen other people do are Scott, one of the guys that I work with, put an indoor air quality sensor next to a room that we were doing 3D printing on, and we were trying
Oh,
to figure
yeah.
out how many VOCs were essentially, what did that look like um, whenever we were 3D printing something with PLA or PETG or whatever. And it was interesting to watch that because it was in an enclosure next to the sensor, and so you could see it kind of move. You could also see it whenever the HVAC system turned on. So you could see
Oh,
the actual
yeah.
effect of, air quality and temperature and everything
Yeah.
on the room. The other one was I think kind of interesting for me. It was my first time using InfluxDB and Grafana as well. Was probably about 10 years ago or so. At my old house, I hacked a home energy meter, and just it was a whole house one. So it had, has the clamps to measure the amperage current flow, and then has a volt, basically a sensor for the voltage and can calculate basically what your energy usage is for your whole house. So I hooked that up to a Raspberry Pi running Ruby actually, and
Oh,
pushed it up to
nice.
Influx. And there's a lot of really interesting surface mount soldering and stuff in that. But what was really interesting about that one was because it's only measuring the aggregate of all of your usage. At the time, machine learning was, as far as like applied machine learning for specific problems like this, was pretty early on. And I found a startup called PlotWatt at the time that was trying to do energy. They called it energy disaggregation. So you could send them the total value, and they would try to identify which appliances and systems in your house were running at any given time from that total sum of all the
Oh,
energy
that's
usage.
cool. Yeah.
They weren't good at it and I don't think they made it. But it was an interesting experiment just to see, because you could look at it visually and you could say, oh, that's where my air conditioning was on.
Yeah.
So to have the computer be able to do that for you was kind of an interesting idea. Um, so those are two really interesting ones that are both time series kind of databases. Like they're both eminently sensor based, and like you can really see the effect of the cause and effect relationships between something turning on and using more energy, or the 3D printer is turned on and running a really big job, and you can kind of see the quality of the air go down a little bit in the room that it's in. It's pretty neat.
Yeah, that's really cool. I love that.
One of the projects that I've looked at, have you ever heard of BirdNet? Like, um, at all? There's basically you can Raspberry Pi or whatever, and you can use a microphone and just help locate birds around your area.
Oh, okay.
So there's
Have to
there's
look
an
it up.
app for your mobile device. Like I have one for my iPhone called BirdNet, but you can also submit it by having like a Raspberry Pi and microphone sitting outside or whatever. And I've thought about doing that, but I haven't gotten that far yet. But I always thought that would be neat to. It does okay. Like the mobile app, when you hold it up with just a built-in microphone, it does okay if the birds are loud enough, and sometimes it's accurate.
Yeah.
So, but they're trying to improve that, and it's out of Cornell, like Cornell Labs or something like that. So,
Oh, okay. Yeah, I'll have to look that up because I use Merlin on my phone, which I believe is also Cornell, and it works pretty well, at least on the phone. So I'll have to look into that.
I dropped the link in the chat there.
Sweet.
And then just the other various projects that I talked about earlier before the recording. So, kind of fun.
Yeah, very cool. I've only got one more slide. I know I'm almost out of time, and I want to leave a little bit of time for questions. So I'll just go through this really quickly. And this is just like practical advice for these kind of projects. And I'm sure most of you are familiar with this kind of stuff already. But always be curious. Don't just let the world kind of happen around you, but be curious about what's going on in your environment and around you and in the world. Um, it will spark all kinds of ideas, and then take those ideas and do something with them. So when you're getting into a project like this, you have to remember to pace yourself. Sometimes it's going to take a while, especially if it's in the few hours of free time that you have outside of work and you run into a problem. It might take you a little while. I can't tell you how many projects I've started, but they're still pending. I haven't finished them. So just pace yourself, be patient with it, and start with something small and then build up. So if I tried to like go straight into machine learning with this, it would have been a huge task that I probably would have gotten burnt out on. But just start with like something that you know that you can accomplish, get that done, and then open up the possibilities and decide where you want to go next with it. So that's all I have as far as the presentation goes. So if you guys have questions or your own project ideas that you want to share, that's what I got.
One of the things that kind of came to mind as you were talking, I have a little bit of, I'm not really involved in it as much anymore, but there's a project in the Elixir ecosystem called Nerves, and you can basically, if you're writing code that would run on a Raspberry Pi, you can treat your code as if it were a firmware. And so you can basically build an Elixir application, and what it does is it stacks that right on top of a very small boot image. So you don't have a typically large running Linux system where you've got system init stuff and all of that. Basically, it boots up directly to something called Erlinit, and then your Elixir application is running. And you can burn it to an SD card and just drop it into a Raspberry Pi, and you're up and running. So you don't have to do a bunch of like flashing and setup after the
Yeah,
fact.
configuration.
Yep. And what's really neat about it too is you can remotely upgrade the firmware as one unit. So it basically compartmentalizes the SD card into two flash areas. And so you can, assuming that you've got remote connectivity to it, you can actually flash a new version of your software, and it'll automatically roll back if there's a problem remotely, which is nice for field deployed things like you got your air sensor maybe at the top of a pole or something, or maybe you got
Yeah.
wind or something up there. So it works really well for that kind of thing. And you can use it with Python libraries as well. Like you can deploy it. It uses build root underneath, and so you can use all the configurability of typical build root stuff. But yeah, I've gotten pretty deep into nerves in the past, and that would be a great application for something like this if you wanted to deploy a bunch of them out and create like a reference database of sound volume or sound noise pollution in different areas.
Yeah,
You could
definitely.
almost produce like a firmware image, right? That has its own configurability for Wi-Fi and everything that pops up as its own Wi-Fi access point. You go into it, you configure it the first time, and then you just kind of set and forget, and then it would everything could call back home. So you could just have other people anywhere that they are get one of these enviros and download the firmware and just run it, and um, that would be pretty cool to have like a I don't know, like a distributed network of noise pollution.
Right. Yeah, make it a lot more stable and scalable.
So are you giving this talk again?
Oh, yeah, I completely forgot to mention that. So I'm going to be giving this at CodeMash this year. So I've got this and one other talk that I'll be taking to CodeMash with me.
I bet
So
there's some interesting noise pollution at CodeMesh.
there probably is. Someone gave me the idea of carrying around like a noise meter during the conference and just like measuring how loud the conference itself is and
Mhm.
sharing that data. That would be fun.
Yeah, that would be really neat. I wonder how much of that would be your own noise, just if you're like shuffling around in your clothes and stuff.
Yeah, that's true. That would be a factor to consider. Or if they would let me like, I don't know, not mount it to the wall, but like put it just somewhere in a hallway or something and
Mhm.
just measure all that ambient noise.
Put one in the water park.
Yes, I'm sure there would be a lot going on there. All right. Well, if there's no other questions, that's all I have. Thank you guys. I appreciate the opportunity to present this to you.
Thank you, Ryan. Good luck on your talk at CodeMash, and I don't know, maybe you'll see a few of us there.